Hello pre-calculus students, and welcome to a video part 2 on using your graphing calculator. I'm demonstrating with the TI-83 Plus. Over the last few years most students have gotten TI-84s, but TI-83 and 84s pretty much do the same thing. There's a couple little differences, but they do the same thing. Okay, so in part 1 you learned how to graph a function, change the viewing window, find x-intercepts, and find y-intercepts. And in video part 2, today, right now, we're going to learn how to solve equations, find local max and mins. Once you have those, we'll see how that leads to being able to determine where the function is increasing and decreasing. Okay, so let's first look at an example. Now, these examples are correlated with your textbook, so you can find some more explanation on how to do them in your textbook. Page 26, example 1, we're going to solve this equation. Alright, now the way you're going to solve the equation is you're going to graph y equals this function. So I'm going to turn on my calculator. I'm going to clear what I have. Go to y equals. I don't care about the equations that are in there. So if it's on the equal sign, I would turn the equal sign off. If it's on any part of the function, I hit clear. It just clears it away. Okay, and I'm going to put in x cubed minus x plus 1. Okay, so in my calculator, that's x to the third minus x plus 1. Okay, and we're going to graph it. Okay, so we're going to go to the standard window, and hopefully that will work. So since I'm not sure where I left my window, I'm going to hit zoom and then go down to 6, which is the 10 by 10 window. Really, it's 20 by 20, but it goes from positive to negative 10, and there's the graph. Okay, now if you want, you can zoom in on this. So I didn't show you this before, but it's pretty simple. You just hit zoom and then zoom in, and then enter one more time, and it just zooms in, just give you a clearer picture. Now we can tell there's one x-intercept, and that x-intercept is the solution for this graph. Now remember, we graphed y equals, but if we set this equal to 0, if we could set it equal to 0, we'd have the solution, right? Because that's what the equation shows, that the same thing equal to 0. So that means we're going to go back to the graph, and we're going to find the 0. Okay, so we're going to go, this is the same thing as finding the x-intercept, by the way, so it's no different from what we did in the last one. So second, calc, and then 0. And now we have to go to the left side of the 0, so it says left bound right here, left bound, I have to go to the left side of it. So I go left, right, until I'm sure that I am to the left of it, hit enter, it creates a left bound. I hit the right button now, and I keep going until I know I'm at the right side of it, hit enter, and it's going to give me the solution between these 2 points. Now this particular function has only one solution, and we're going to find it right now to the nearest, to a decimal place anyway. Okay? Now later we will be able to find solutions like these exact solutions when they're rational or even when they're irrational. But for now, this is a fast way to get a good idea of what the solution is. Okay, so there you have it. Okay, let's look at another one. Now, what if it's not solved for 0? Okay, well, you've got two choices. You can solve it for 0, but I'm going to show you a different way to do it so you can just kind of see how this works. All right, so we're going to go back to y equals, clear out what we have, and put the two sides of the equation in as separate graphs. Okay, so y1 is going to be 4x to the 4th minus 3. So 4x to the 4th. Minus 3. Remember, use subtraction, not negative. Just go down to the next, and y2 is going to be 2x plus 1. So 2x plus 1. Alright, now they're both darkened, so when I hit graph, they're both going to give me that graph on whatever the last window was that I used. I want to go back to zoom 6. So I'm going to go back to my standard window, zoom 6, and let's see what we get. Okay, there's a parabola, that's the first one, and there's a line, that's the second one. I'm going to zoom in so I can see these a little bit more clearly. So zoom in, enter. There's the parabola. Oh, it doesn't quite make it. So I'm going to go just a little bit higher so I can make better use of my screen. So I'm going to see what my window is right now and make it a little bit higher, that's all. So right now my y max is 2.5. Why don't I just make it 4? And now let's see what we get. We get enough of the parabola and enough of the line to see the intersections. Okay, now there's two solutions to this. As you can see, there's two places where they intersect. So now we're going to see how to use the calculator to find a point of intersection. Okay, so this is in the same place as you do everything else, which is in Calc. So we're going to go to the Calc menu right there. All right, so second, Calc, and then you see number 5 says intersect. That's the one we're going to use. So you can either scroll down to 5 or you can just hit the number 5 and it's going to ask you for the intersection of which curve. Now sometimes your cursor is visible, like right now. Sometimes it's not, and you have, like if it started out down here, you may not know where your cursor is. You can look down here and see where the cursor is, but you really want to see it. So I'm going to go to the left one. I'm going to keep on going around the bottom of the parabola until I can see it. Okay, now I'm on the first curve and I'm going to look for this intersection first. So I hit enter because I'm on the first curve, and as soon as I hit enter, it jumps to the other curve. Let's just make sure. See now if I move left and right, I'm never moving up and down. Okay, I'm only moving left and right. I'm on the second curve. I hit enter and it says guess, and I don't know exactly what that means, but if you hit enter then, as long as you're near the point you want, it will give you an intersection. So x equals about 0.87. All right, we don't really care what the height is. We're looking for the x's where they intersect. Okay, that's the solution. That's one of the solutions. Now we do it again for the other solution. So we hit second Calc. Now we're going to do intersection again. We move the cursor around the bottom of the parabola till we're near where we want to be. I'm going to the right, and I'm pretty near it now. I know I'm on that curve, so I hit enter. It jumps to the other curve. I just like to make sure I'm on the other curve, and I hit enter, and now it's going to find one in this area. And there's the other intersection, 1.12. Okay, those are the two values that if you plug into this equation, the 1.12 and the other one that we found, that will give you these two sides of the equation being equal. Okay, let's move on to finding local max and mins. So we're going to look at this equation, which is 6x cubed minus 12x plus 5. Sometimes they will come in decimal form. They'll be longer than that, but they all work the same. All right, I'm going to clear out what I have. Remember, any place on the equation, hit clear and it goes away. Make sure your plots are off. And we're going to put this equation in here, and they also give us the x for the window, so from -2 to 2. What I'm looking for is any local maxes or mins between -2 and 2. So let's graph this. Y equals 6x to the third minus 12x plus 5. All right, and I'm going to check my window this time. I'm not going to go to zoom 6. I want to use what they tell me to use here. So it's for the x's anyway. So from -2, not subtract 2, but -2. Remember, on the bottom you want to use negative, not the subtraction. You're going to get an error. If you try to subtract and there's nothing, or in this window, you'll get an error. X max is +2, and we'll keep the scale at 1. And I really don't know what to expect for the y's, so I'm just going to put -10 to 10. All right, let's see what we get. Okay, so we did get a pretty good idea of what the graph looks like, but since we're specifically looking for a max right now, I think we should really increase the y max a little bit here so that we can see the top. So let's just make this, if this was 10, let's make it 15 and see what happens. So y max, 15. Check the graph again. And there we've got the whole graph. Now this is in the same place. We're basically learning everything in the calc section here, all the things that we can do with this. So we go to calc, and there's a place for minimum and maximum. Now just to remember, we're looking for a maximum here, and then we're going to look for the minimum over here. These are local maxes and mins. All right, this is all you can find with this is local maxes and mins. So let's go to second calc. We're going to go for that maximum, enter. And the same way that we had to for intercepts, we have to get a left bound, so I have to keep on going to the left. I'm not using the up and down keys. Go to the left till I know I'm on the left side, and then go to the right till I know I'm on the right side, and I've already gone on my way down. Hit enter one more time, and there we have a local max at x equals -0.82 approximately, and y equals about 11.5. So let's write this down. I'm going to show you how I want you to draw these out. All right. So I made a rectangle, and this is how I want you to show your work when you use a graphing calculator. I made a rectangle. I need to have the window there. So I'm going to go to the window, and I know my x min is -2. My x max is +2. My y min is -10. And my y max is 15. Okay, so you want that information there, or the graph doesn't really mean much. Okay, let's go back to the graph. We found the min, but I think I just cleared it, so I'm going to find it real quick again. So the minimum, enter, to the left, enter, to the right, enter, and then enter one more time. So this point right here is that different than what we had before? Oh, because I hit minimum. Let me do this again. Second, calc, maximum. Enter, to the left of the maximum, enter, to the right of the maximum, enter, and here we go. So there's a max at -0.82, 11.5. Okay, let's find the min over here. Okay, I'm going to pause it. You guys can work on it, and then we'll see if we get the same thing. Okay, so I have my local min here at 0.82, and then -1.5. It's different. It looks like it might have some kind of, it looks like the positive and negative x's might be really similar, but I think that might be more of a coincidence. But there's a min at 0.82 and -1.5. Okay, so this is the min right here. Now that tells us about where it's increasing and decreasing. So now we can say that this function is increasing over the interval that we're looking at. So this is only on the interval from -2 to 2, because that's what we were given for this problem. It's increasing from -2, and since that's an open interval, this is an open interval, up to -0.82. And remember, whenever you're increasing, it's always an open interval anyway. It's decreasing from there to there. So from the local max to the local min, it's going down. So it's decreasing from -0.82 to +0.82. And then it's increasing again from 0.82 up to 2. Okay, so we got a lot of information there. We really were able to get, from the equation alone, we were able to get the local max, the local min. Of course, we know the domain for this interval from -2 to 2. We could even look at the range a little bit, but that would be another challenge to figure out what the highest point is, and we're not going to bother with that right now. And that's how you find the local max and min. Okay, I hope you found this video helpful.